Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook, this one question type lost more marks than almost any other on last year's higher tier papers, completing the square. And most of those marks were lost for two tiny mistakes, a sign error and failing to handle the coefficient a properly. Stick with me for 3 reliable steps and you will stop losing those marks.
Right, quick promise. By the end of this episode, you'll have a 3-step routine for completing the square. You will know exactly how examiners award M and A marks, and you'll have a 10-second check that catches most errors. Sound good? Let's begin with the concept.
The concept. Why complete the square? Think of ax squared plus bx plus c. Rewriting it into vertex form, a times x minus h squared plus k does two things. 1. It reveals the turning point straight away, because the expression inside the square is 0 at x equals h. 2. It makes exact minimum or maximum values accessible without graphing. So understanding the algebra matters, not just following a recipe.
Step 1. Factor the leading coefficient if a isn't 1. If you have ax squared plus bx plus c, write it as a times x squared plus b over ax, then plus c. We do this because completing the square inside that bracket works like the unit case, x squared plus px. If you forget to factor out a, you'll end up with misplaced constants and that sign error I mentioned.
Step 2. Complete the square inside the bracket. Take the coefficient of x inside the bracket, call it p, and add and subtract p over 2 squared. The algebraic trick is we add 0 in the form plus p over 2 squared minus p over 2 squared. So the expression can be rearranged to a perfect square plus a constant. You're not changing the value, you're rewriting it in a cleaner form.
Step 3. Tidy up and multiply back the factor a. Combine the perfect square term and the constants and you'll end up with a by x minus h squared plus k. That h is the x-coordinate of the turning point, k is the y-coordinate. If a is positive, it's a minimum. If negative, it's a maximum. Simple in idea, but the arithmetic needs care.
Let's use a concrete example so this doesn't stay abstract. Complete the square for 2x squared plus 8x minus 3 and find the turning point. I'll say each line exactly as you should write it in an exam.
Right. 2x squared plus 8x minus 3 equals 2 lots of x squared plus 4x minus 3. Notice I've factored the 2 out of the x terms. That's M1 material. Correct rearrangement.
Next, inside the brackets, complete the square. X squared plus 4x equals x squared plus 4x plus 4 minus 4, because 4 over 2 squared is 4. So 2x squared plus 4x minus 3 equals 2 times x squared plus 4x plus 4 minus 3. Group the perfect square.
Now rewrite is 2 brackets x plus 2 squared minus 4 minus 3. Expand the constant is 2 x plus 2 squared minus 8 minus 3. So final form 2 brackets x plus 2 squared minus 11. From this, we read the turning point at x equals minus 2, y equals minus 11. That's the answer you'd box. See how each algebraic tweak maps to the final numbers.
The logic behind the minus signs matters. When we added plus 4 inside the bracket, we actually subtracted 2 times 4 outside once we multiplied by 2. That arithmetic is where students lose marks. Small sign slips become lost marks. Let that sink in.
Exam technique. How marks are awarded.
In a typical GCSE question, you'll see M1 for correct rearrangement or setting up the expression ready to complete the square, another M1 for the actual completing the square step, the perfect square written down, and A1 for the exact final value or coordinates. So a 3-mark question often splits as M1, M1, A1. If you show a correct method but arithmetic slips, you still pick up method marks. That's why writing down the method is crucial. Write it down, don't just think it.
Common examiner penalties: not factoring out a k, forgetting to balance the added square by subtracting the same amount, and arithmetic when multiplying constants back. Also, if you convert to decimals too early, you can lose the A mark for an exact value. Always aim for exact surds or fractions when the question expects them.
The quick win, a 10-second check you can do every time. Substitute your found turning point back into the original expression. It takes 10 seconds. If your x gives you the y you wrote down, tick the answer and move on. That catches sign or factor errors immediately.
Quick mental checklist before you move on. 1. Did I factor out a from the x terms? 2. Did I use b over 2a squared inside the bracket? 3. Did I multiply the subtracted square? Quick mental checklist before you move on. 1. Did I factor out a from the x terms? 2. Did I use b over 2a squared inside the bracket? 3. Did I multiply the subtracted square by a when I took it out? 4. Did I substitute the turning point back into the original to check? If any answer is no, pause and fix it.
Worked example and practice prompt. I'll run through one past paper style question exactly as you'd write it, then give you one to try. Question. Complete the square for 3x squared minus 12x plus 5 and find the turning point. First line. 3x squared minus 12x plus 5 equals 3 times x squared minus 4x plus 5. That's M1 for correct rearrangement.
Next, inside brackets x squared minus 4x. Complete the square by adding and subtracting 4, because minus 4 over 2 squared equals 4. So 3x squared minus 4x plus 4 minus 4 plus 5 equals 3x minus 2 squared minus 4 plus 5. Expand a constants equals 3x minus 2 squared minus 12 plus 5 equals 3x minus 2 squared minus 7. Turning point, x equals 2, y equals minus 7. That's M1, M1, A1 in action if the marking scheme is 3 marks.
Practice prompt. Pause the podcast now and try this one. Complete the square for 4x squared plus 16x plus 1 and give the turning point. Use the 3-step routine. Factor, complete the square, tidy up. I'll give you a few seconds to work it out.
Back? Great. If you work through it, you should have 4x squared plus 4x plus 1 equals 4x squared plus 4x plus 4 minus 4 plus 1 equals 4x plus 2 squared minus 4 plus 1 equals 4x plus 2 squared minus 16 plus 1 equals 4x plus 2 squared minus 15. So turning point at x equals minus 2, y equals minus 15. If your answer differs, check the factor and the multiplied constants.
That's your quick win for today. If this helped, share it with a friend who's revising. You can find more worked solutions and printable practice sheets at jcacademyonline.co.uk. Stay curious and trust the process. Until next time, nail that exam.